Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello everyone, good evening. Hello everyone, good evening. First of all, wish you a very happy Eid Mubarak to all of you, and also happy Akshaya Tritiya. So I'm those who have already attending the class, you people know it very well that we have already completed the first chapter of environmental engineering. Welcome to this channel of Testbook, and we are discussing the environmental engineering for your gate process, and we have already completed the first chapter, that is population forecasting and water demand. We will solve today itself, we will solve certain questions from that population forecasting and water demand. Before going to solve the questions, वो क्वेश्चन सॉल्व करने से पहले हम लोग अभी चलते हैं द सेकेंड चैप्टर व्हाट दैट विल बी सोर्स एंड कन्वीनियंस ऑफ वाटर, ये चैप्टर पढ़ने के लिए। ये एक चैप्टर है जिस चैप्टर में एक्चुअली ये चैप्टर हाइड्रोलॉजिकल प्रोसेस का चैप्टर है। इस गेट मतलब इन्वायरमेंटल एस्पेक्ट से उतना ज़्यादा कुछ है नहीं। खैर ये चैप्टर उतना इम्पोर्टेंट भी है नहीं। जस्ट यू नीड टू नो दिस द बेसिक्स ऑफ दिस चैप्टर एज पर द what to say it just as per the flow of this studies। क्योंकि क्या है पहले चैप्टर में किस चीज़ के लिए कितना डिमांड है पानी का, और उसके हिसाब से मतलब कितना डिमांड हो सकता है, किस कंपोनेंट का कितना डिज़ाइन डिमांड है, कितना टाइम पीरियड के लिए ये कंपोनेंट सस्टेन करना पड़ेगा, एवरीथिंग इज डिस्कस्ड नाउ। दैट इज द फर्स्ट चैप्टर। इन द सेकेंड चैप्टर एंड तो अभी क्या करना है, कितना पानी आपको सप्लाई करना है उतना मालूम है। अभी व्हाट यू नीड टू डू, यू हैव टू सर्च अ सोर्स ऑफ वाटर। आपको ढूंढना है एक पर्टिकुलर सोर्स, जिस सोर्स से आप पानी को लेके उसको ट्रीट करते हुए उसको आप सप्लाई करोगे फॉर द डोमेस्टिक यूजेस। सो व्हाट यू आर सर्चिंग right now, you are searching for a source of water by applying which you are going to treat the water, and that treated water will be further supplied for the through the domestic process. That is the actual aim. Okay, So this is a chapter 2 where we are going to discuss about the source of water. The source of water will be of two types. One is surface source, another one is subsurface source. Surface source and another one is subsurface source. The surface sources are, which is the water, those who are actually exposed to the atmosphere, and they are nothing but ponds and lakes, streams and rivers, reservoirs, etc. So pond, lakes, stream, rivers, reservoir, etc. are the surface source. And what are the subsurface source? Subsurface source is spring, infiltration work, wells, etc. Subsurface source is spring, infiltration work, wells, etc. These are the subsurface source. Now, what is spring? Spring is the natural outcropping of subsurface source, means the source, वही source है जो पानी मिट्टी के नीचे, या the source which is actually submerged beneath the ground surface. The source which is submerged beneath the ground surface, that is subsurface source. Now, subsurface source will be spring, infiltration works, well. So what is spring? Natural outcropping of groundwater. Spring is nothing but the natural outcropping of groundwater. Spring is nothing but the natural outcropping of groundwater. And in case of spring, the quality of the water will be very good, whether the quantity will be less. For the spring, the quality of the water will be very good, whether the quantity will be less. That is for the spring. Now, what is infiltration works? Infiltration works will be of two types. One is infiltration gallery, another one is infiltration well. Infiltration works will be of two types: infiltration galleries and infiltration well. Now, what are they? To collect infiltrated water at the bank or bed of river. These infiltration works are used to collect the infiltrated water. Infiltrated water means the water which is actually flowing through the soil pores after the runoff. So runoff के बाद जो पानी, जब precipitation which is actually flowing through the soil pores according to the force of gravity, that will be called as the infiltration. Now, to collect the infiltrated water at the bank or bed of river is called as infiltration work. And the infiltration work will be of two types. One is infiltration galleries and second one is infiltration well. What is infiltration gallery? That is the tunnel dug at shallow depth at the bed or bank of river. That is the tunnel dug at shallow depth at the bed or bank of river. That is infiltration gallery. That is the tunnel dug at shallow depth at the bed or bank of river. Now, what is infiltration gallery? The infiltration well, hole made in the water bearing stratum at the river bed or river bank. There is a hole made in the water bearing stratum at the river bed or river bank. That is infiltration well. So infiltration gallery is the tunnel dug at shallow depth at the bed or bank of river. And infiltration well is the hole made in the water bearing stratum at the river bed or river bank. That is infiltration well. And what about the wells? Wells are nothing but the vertical hole made in the ground to tap the groundwater. सो ये एक वर्टिकल होल है जो ग्राउंड में बनाते हुए जो टू टैप वो ग्राउंड वाटर को पकड़ने के लिए. And these wells are of two types, open wells or dark wells. These wells are of two types, open wells or dark wells. What is open well or dark well? Diameter of this open well or dark well are in between 2 to 9 meter, and depth should not be more than 17 meter. Diameter will be 2 to 9 meter and depth will not be more than 17 meter, and water yield 2 to 6 liter per second. Water yield 2 to 6 liter per second. Open well or dark wells, dia 2 to 9 meter, depth not more than 17 meter. Water yield will be in between 2 to 6 liter per second. Then tube well or bore well. A tube well or bore well, dia 15 to 30 meter. Dia 15 to 30 centimeter, sorry. Dia will be much lesser than the open well or dark well. And depth 20 to 70 meter, depth 20 to 70 meter, and water will be much higher than the open well or dark well. It will be 15 to 45 liter per second. So that is the comparison between two type of wells, open wells and tube well. So in the open well, the diameter will vary in between 2 to 9 meter, depth should not be more than 17 meter, where water will be yielded at a rate of 2 to 6 liter per second. Whereas for tube well, dia will be in between 15 to 30 centimeter and depth will be 20 to 70 meter, and water will be yielded at a rate of 15 to 45 liter per second. Now we'll go for the in-text. It is nothing but not a source, but in-text. That's a special type of thing, which is what? In-text, it is a structure constructed at surface water body for safe withdrawal of water over a predetermined period. It is a structure constructed at surface water bodies for safe withdrawal of water over a predetermined period. It is called as an intake. It is a structure constructed at surface water bodies for safe disposal, withdrawal of water over a predetermined period. And this intake will be of three types. This intake will be of three types. For the collection, storage and deliver. For the collection, storage and deliver, intake will be called as wet intake, or example is river intake. For the collection, storage and deliver, the intake will be called as wet intake, as example river intake. For the collection and deliver, the intake will be called as dry intake, and example is reservoir intake. Yes, the storage is not there. And there is another type of intake, which is in submerged in water, as example lake intake, which is called as submerged intake. That is intake submerged in water, as example lake intake. Now, apart from the source of water, then we need to know for the conveyance of water. The conveyance of water will be of two type. Now, generally conveyance किस तरीके के होते हैं? Actually ये तीन तरीके के हैं. One is gravity conveyance, second one is pressure conveyance, and third one is gravity pressure conveyance. But actually third one is the combination of first two. थर्ड वन एक्चुअली दोनों का कॉम्बिनेशन है. तो ग्रेविटी कन्वेंस में क्या होते हैं? ग्रेविटी कन्वेंस में वो ओपन चैनल फ्लो है. एग्जांपल मतलब वाटर विल बी for the gravity conveyance, open channel flow. Pressure conveyance is actually example is pipe flow. So pressure conveyance where required pipes, pumps, etc. And pressure conveyance is preferred to gravity conveyance because of lesser losses, and also we can say that it is preferred for quick transportation or conveyance of water from one place to another. Now to design the pressure conveyance, two type of things are there: fixing the size of the pipe and fixing the capacity of the pump. To design the pressure conveyance, two things will be there. One is fixing the size of the pipe and fixing the capacity of the pump. Only we need to know, though you have gone through in your fluid mechanics part, one is the two equation. One is Hazen-Williams equation, another one is Darcy-Weisbach equation, where HL, for the Darcy-Weisbach equation, HL is head loss is FL V square by 2 GD, where F is the friction factor, L is the length, V is the velocity of flow, and D is the diameter of pipeline. Or it can be written as FLQ square by 12.1 D to the power 5. Q is discharge. ये इक्वेशन जो डार्सी-वीसबेच इक्वेशन है आपको याद रखना पड़ेगा, so that you can proceed further. You need to remember this, very important, all those things. Hazen-Williams equation is another equation where V is 0.85 CH, R to the power 0.63, S to the power 0.54, and Q equals to AV. That continuity equation will be also used, where here CH is called as Hazen's constant. CH is called as Hazen's constant. R is hydraulic radius. This is not normal radius, it is area by weighted perimeter. A by PW. Suppose this is one rectangular cross section, side A, B and A. Normal perimeter is 2 into A plus B. But weighted perimeter is that particular sides which is actually weighted by water. It's 2A plus B. AC side slope. Which is equals to H by L. Okay. Now quickly have a look what we have read till now. We'll solve 2-3 questions and we'll finish this chapter. These are the infiltration works. These are the wells. These are the intakes. That is conveyance of water. That is the Darcy-Weisbach equation and Hazen-Williams equation that we are actually concerned about. That is the explanation. And let's solve certain questions to get to fulfill the demand of this chapter, and then we will proceed further. So first is question number 1. A town with population 50,000 supplied water at a rate of 200 LPCD draw water from a source which is 10 kilometer away from it. Elevation difference between source and supply is 8 meter. Find the dia of the conveying pipe. If friction factor is 0.01. Please solve. I am giving you 2 minutes time to solve this question. Please solve. Let's see. The solution process. Head loss will be FLV square by 2GD, or it is 12.1, sorry, FLQ square by 12.1 d to the power 5. So first we need to calculate Q value, which is Q average, which is nothing but population into per capita demand. That is 50,000 into 200 LPCD. It will be liter per day now, but we need to convert into meter cube per second, then only we can proceed. It is coming as 10 into 10 to the power 6 liters per day. That is equals to 10 into 10 to the power 3 meter cube by 24 into 3600 per second. That is 0.1157 meter cube per second. So here, what is head loss? Elevation difference 8 given, that is equals to F is 0.01, L is 10 kilometer, 10 into 1000 meter. What is Q? 0.1157 whole square whole by 12.1 d to the power 5. From here only unknown is d. Final answer d will be 0.42 meter. 0.42 meter. Please have a look. Now we are going for solving the next question. Question number 2. Ten mld of water is supplied in a town which is 8 kilometer away from supply. Elevation difference is 10 meter. Find the dia of conveying pipe. Find the dia of pipe if CH is equals to 100. Please solve this question. Once again, giving you 2 minutes time to solve. Let's solve this question. So once again here Q is 10 mld, that is equals to 10 into 10 to the power 6 liters per day, which is already we have seen it is 1157 meter cube per second. We know that V is equals to 0.85 CH R to the power 2 by 3 and S to the power R to the power 0.63 S to the power 0.54. This is 2 by 3 S to the power half 0.54. What is R? R actually area by weighted perimeter. For a circular pipeline, area is pi by 4 d square. Weighted perimeter is 2 pi r, that is pi into d. It's g by 4. So it is 0.85 into 100 into d by 4 to the power 2 by 3. S is h by l to the power 0.54. We know q equals to a into v. That is, q is actually 0.1157 is equals to a is pi by 4 d square into v is 0.85 into 100 into d by 4 to the power 2 by 3. H by L is 10 by 8000 because 8 kilometer to the power 0.54. From here only unknown is d. D will be 0.49 meter. D will be 0.49 meter. Is that clear? Have a look to this question. Let's go for question number 3. Let's go for question number 3. That is question number 3. What is the strainer length required for a deep tube well giving a discharge of 8 liter per second? Assume permissible entrance velocity of 2 centimeter per second. It is desired to have the strainer of slot sizes 20 mm cross 0.2 mm with number of slots per centimeter length of strainer as 100. Please solve this question. Let's solve this question. So total area of slots required is Q by V is equals to 8 into 10 to the power minus 3 by 2 into 10 to the power minus 2, that is 0.4 meter square. Area of each slot is equals to 20 into 0.2 mm square, 4 into 10 to the power minus 6 meter square. So number of slots required total area of slots by area of one slot. What is total area of slot? 0.4 by 4 into 10 to the power minus 6. This much. So length of pipe required is equals to total number of slots by slots per centimeter length. So total number of slots is 1 lakh. Slots per centimeter length is 1. Hundred. So it's 1000 centimeter, which is 10 meter. Hope you got this question. Please see question number 3. That is the end of source and conveyance of water. So if you want to summarize the different source, surface source and subsurface source, then infiltration wells, works, wells, intakes, conveyance of water, and those equations, Darcy Weisbach and Hazen-Philem equation. On these 3 questions for your better understanding. That is all about the source and conveyance of water. That is all about the source and conveyance of water. Now we will go to the question discussion of population forecasting and water demand, the first chapter. Now we will go to the question discussion of population forecasting and water demand. First two questions. Which one of the following practices causes reduction in the per capita water consumption? Option A, Rahul. How are you? Good evening. Rahul Sudradasi. Rahul, from where you are? Are you there, Rahul? From where you are? So, which one of the following practices causes reduction in per capita water consumption? Four options are there: good quality water, hotter climate, modern living, metering system. What will be should be the answer? Please tell me. Which one of the following practices causes reduction in the per capita water consumption? Good quality water, hotter climate, modern living, and metering system. The good quality water, obviously, if the quality of water is good, the consumption will be more. Hotter climate, obviously consumption will be more. Modern living will be more. Metering system, obviously if metering system means cost is involved, then consumption will be less. Option D will be the correct answer, as they are asking for the reduction. As asking for the reduction. Vishabhadra, how you are telling A? Good quality of our water, how can it reduce the per capita water consumption? হ্যালো, উপরে আয় একবার। বাদলদাকে বলি যে পুজোর প্রসাদ রাখা আছে, এখনই বল যেন একবার ফেরার সময় নিয়ে যায়। তাও বলে দেন। Okay, okay, Vishwadra. The question number 2 is the multiplying factor as obtained to applied to obtain the maximum daily demand in relation with the process. What will be the answer? So Qmax daily will be nothing but 1.8 into Q average. So option B will be the correct answer. Option B will be the correct answer. Hope it is clear. Now going for question number 3. The multiplying factor as applied to obtain the peak hourly demand. The multiplying factor as applied to obtain the peak hourly demand in relation to the maximum daily demand is the multiplying factor as applied to obtain the peak hourly demand in relation to the maximum daily demand will be, so Qmax hourly is equals to 1.5 into Qmax daily, which is 1.5 into 1.8 into Q average. So 2.7 into Q average. So this will be option A, and this one will be 2.7, option D. The same explanation is already there. दाएं तरफ explanation है, आप देख सकते हो. Question number 5 and 6. The total water requirement of a city is generally assessed on the basis of the total water requirement of a city is assessed on the basis of water requirement means total demand will be the maximum of total demand will be the maximum between coincidence demand and Qmax hourly. So, and coincidence demand is nothing but Qmax daily plus fire demand. The total water requirement of a city generally assessed on the basis of greater of A and B. Greater of A and B. Greater of A and B. Vishavadra, please mention the question numbers. Otherwise, it's tough to understand. Coincidence draft to water demand is actually maximum daily plus fire demand. So the explanation of question number 6 is also there. That is question number 5 and question number 6. Question number 5 and question number 6. Textbook pass is one pass for all the complete learning of 100 plus exams. Whatever exam you are actually going for, you can avail this textbook pass. 100 plus courses, 6,500 6,500 से ज़्यादा mock test, 38,000 plus selections, expert guidance, exam strategy videos, everything is there in textbook pass. So don't be late. Avail today a textbook pass for your better and proper preparation. Question number 7 and question number 8. The distribution system in water supplies is designed on the basis of the distribution system in water supply is designed on the basis of greater than A and B. B and C. As compared to the geometrical increase method of forecasting, arithmetic will give lesser value. We have already solved the questions, we have seen this concept, everything is done to us. हर चीज हम लोग पढ़ चुके हैं. Now, question number 9. The suitable method for forecasting population for an old and developed cities. Old and developed cities के लिए क्या होगा? Quite obviously arithmetic mean method. आपके पास नोट पे है, just follow the notes here. The suitable method for forecasting population for old and developed cities, arithmetic mean method. The pipements carrying water from the source. The pipements carrying water from the source to the reservoir are designed for it will be maximum daily demand. Question number 11. The design period for the design of water supply project is generally taken as you people know it very well, 20 to 30 years. Question number 12. Filter and other units of treatment plant are designed for option A, the annual average daily demand of water. Option B, 2 times of the annual average. Maximum daily demand of water, 1.8 times the annual average daily demand, or 2 times the maximum daily demand of water. Filter and other units. Option C will be the correct answer. Hope you people know it very well. As per 1172/1993, in the design of a water supply structure scheme for a town with full flushing system, minimum water supply for domestic water demand will be minimum is 135 to 200 LPCD, because the range is 135 to 200 LPCD. The suitable method for forecasting the population of a young and rapidly developing city. Young and rapidly developing city, quite obviously we will go for geometric mean method. quite obviously we'll go for geometric mean method. Question number 15. The per capita per day demand of water is taken as an average value over a period of 24 hours, 1 year. It's an annual average, so it will be obviously 1 year. Question number 16. Water distribution system are sized to meet that A और C दोनों हो सकते हैं और मैक्सिमम ऑफ दिस टू. Question number 17 and 18. The growth of population can be represented by a logistic curve or S curve. Question number 18. Please solve. So Q average is given as 24,000 cubic meter. So meter cube per day, that is equals to 1000, just dividing it by 24 meter cube per hour. They're asking for peak hourly demand, Q max hourly. Is 2.7 into 1000. It will be 2700 meter cube per hour. So quite obviously option D will be the correct answer, 27 cubic meter per hour. Hope you got the thing very well. Question number 19. If the population of a city is 2 lakh and average water demand is 200 LPCT, then capacity of the pipe mem carrying raw water from source will be how much? Question number 19. Please solve. Vishavadra has replied. And he has replied correctly. Question number 19. So population is 2 lakh. So Q average is 2 lakh into 200. Is 40 mld. So actually from here you will get as 40 into 10 to the power 6 liter per day. It will be mld. And pipe source capacity of pipe means capacity of pipe mem will be 1.8 into cube average. It's 72 mld. Option B is the correct answer. Solve this. Question number 20. Let's solve this question. So find the population at the end of 2011. So what is the given? 1 lakh, 1 lakh 9,000, 1 lakh 16,000, 1 lakh 28,000. X values will be 9,000, 7,000, 12,000. So what will be your X bar? 28,000 by 3. Now 2021 P20 last known decade is 1981. Here P3 into that's P3 is equals to P0, 1 lakh 28,000 3 into 2800, 20,000 by 3. Answer will be 1,56,000. 1,56,000. Option D will be the correct answer. Option D will be the correct answer. Hope it is clear to you. Now, question number 21. The population figures in a growing town are as follows: 70, 40,000, 80, 46,000, 90, 50,000, 20,000, 50, 58,000. Now it is very easy to solve after the previous question. 40,000, 46,000, 53,000, 58,000, 6,000, 7,000, 5,000. X bar is 6,000. So P 2010, it will be 58,000 plus 1 into 6,000, 64,000. Now this one is question number 22. Let's take it as assignment question. Now, question number 23. The population of India in the year 2000 was 1 billion and increased in exponential manner 1.6% per year. This is assignment question 2. That's question number 23. Question number 24. The present population of a community is 28,000 with an average water consumption of 4,200 meter cube per day. The existing water treatment plant has a design capacity of 6,000 meter cube per day. It is expected the population will increase to 44,000 during next 20 years. This is the gate question. the number of years from now when the plant will reach its design capacity. Please do it also. Assignment question 3. Okay, so let's summarize today's class. We have started with the discussion of the source and conveyance of water, source, surface source, subsurface source, different sources like spring, infiltration work, then well, then intake. Everything we have gone through. We also gone through the conveyance of water. Then we have checked it out to equation, Hazen-Williams equation, and the Darcy-Weisbach equation. We have explained it clearly, and then we have solved 3 questions of this chapter, source and conveyance of water. Then we have started the discussion of the population forecasting and water demand, and we have completed certain 20 questions over there, and rest of the questions, 3 questions I have given you for your assignment, will solve in the next class. Hope you have liked the class. Sometimes some dizziness is there, and see you in the next class. Next class we will start the most important chapter of this domestic water supply engineering part, that is quality of water. That is quality of water. Okay.